Hello everyone. Note down this question. There are two oscillators with time periods T and 4T, and they both start from mean position, their respective mean positions. X equals to 0, X equals to 0. They can have different amplitudes or same amplitudes, it doesn't matter. Their time periods are given as T and 4T. The question is, after what time these oscillators will be in same phase for the first time. At the beginning, at t equals to 0, at t equals to 0, they are in same phase. They both start at t0, t0, and they are at the mean position. The question is, write down the question, after what time both oscillators will be in same phase for the first time. After what time both oscillators will be in same phase for the first time. Let's understand meaning of this question. Everybody knows about circular motion interpretation of simple harmonic motion. So these two oscillators, they are basically this. Let's say first one has an amplitude of A1, second one has an amplitude of A2. This is A1, and this is A2. So you've got two rods of different lengths, A1 and A2. The upper one is A1 and the lower one exactly the same position, but just so that you can see it, I've drawn it this way. This A2 is rotating with an angular velocity of omega 2. What is omega? Omega is 2 pi upon T2, which is 4T. And the inner one, this one, is rotating with omega 1, and your omega 1 is given by 2 pi upon T1, which is T. That means if I say that this is omega, then this becomes what? 4 omega. So if angular velocity of A2 rod is omega, then that of A1 is 4 times omega. So this smaller rod is faster. It has nothing to do with smaller and larger lengthwise, but just so that you can see both figures, I've drawn it this way. Now, try to visualize this. There are two rods with different lengths. The black one starts from this position up to here, and they are rotating. Initially, they are in the same phase. What is phase? Phase is angular position. So, at T0, they both are at the mean position. Both rods, they have an angle of 0 from the horizontal. But smaller rod is faster, and therefore after some time this is going to happen. They are out of phase. They started in same phase, but just after this moment, since blue one is faster, there is an angle difference. That means there is a phase difference. Now the question says, when will they both be in same phase? So the question says, find out that time, whatever it is, when you find that both are making same angle from the horizontal. Just after T0, this happens. But after some time, these two are going to form same angle. What is that time? That's what the question is. Now try to answer this. Write down the meaning of phase. We need to find that time when both rods make same angle from the initial horizontal position. Question is basically for competitive examinations, but the concepts you gain, you can use them in any examination, school or competitive. Give it 30-40 seconds and I hope you can answer this. Now, again, let's visualize this question. What is phase? Phase means this is the rod initially, after some time it is found here. This angular displacement theta is nothing but phase. So in this question, you have two rods. One is slow excuse me, and the other one is fast. So what happens? जो फास्ट होगी तो पक्के से कहाँ निकल जाएगी आगे. But since it's faster, it covers more angle, but it's a circular path. After some time, the faster one is going to overtake the slower one. Try to visualize this part. The faster one, the blue one, the faster one is going to overtake the slower one at some point of time. When it does that, you will say they both are forming same angle from the horizontal or the initial point. So you need to find that time when they both are forming same angle. That's what the question is. How do we answer this? Look here. Let's say this thing happens when rods are like this. This is A1 and this is A2. Up to this point A1 and up to this point A2. They are subtending same angle theta. But there is something special. Since they both start at the same point and the blue one is faster, it's not that it is going to take place just in the beginning. Just in the beginning. No, it will be something like this. The faster one completes a round and then overtakes the slower one. I hope you understand what I'm saying. That means the faster one has completed one rotation, one complete rotation, and then it comes and overtakes the slower one. If somebody uses theta, angular displacement, as omega t, angular velocity multiplied by time, and if they use this, that omega 1t, this is time t when they are forming same angle, and somebody uses this, then you will never find the correct value, because omega 1t can never be omega 2t. Omegas are different. तो हुआ क्या था, फिर से देखना, यहां से शुरू किया, ब्लैक स्लो है, ये अभी तक यहां पहुंची है, ब्लू फास्ट है, इसने एक राउंड कंप्लीट किया, and then it overtakes. What is the meaning of it has completed one round? So if it has completed one round, then theta for A2 and theta for A1, they are basically not same. It looks as if they are forming same angle, we'll call it what, same phase, but angular displacement wise, the faster one has covered more angle. This is sufficient hint, but let's complete the question in this form. It will be easier for you to understand this. If this angle is 120, suppose we have taken some random value which is 120, not necessarily over here, it can take place at this position also, it can take place somewhere here also, it can also take place somewhere here depending on their angular velocities, but say this angle is what, 120. So this is 120. 120 of the slower one is equivalent to 360 plus 120. It's not equal. Is equivalent to 360 plus 120 of the faster one. Again, if I say this angle is 120, this is the horizontal line for reference frame. If I say this angle is 120, and then if I say one complete round and another 120. So if I ask you what is the angle between horizontal line and this black marker after 360 and 120, you're going to say angular displacement is 360 plus 120. But if I ask someone who looks at this setup for the very first time, is only going to say that angle is what? 120. So for us, 120 is equivalent to 360 plus 120. The only thing left is how to equal both things. How can you make both parts equal? So you can make both parts equal if you say this. The faster one, which is omega 1, in time t, it covers this much angle, faster one, which is 360 plus angle covered by the slower one. Omega 1t is equal to 360 plus omega 2t. That's what is the answer. What is omega 1? 2 pi upon t1. What is 360? 2 pi. What is omega 2? 2 pi upon t2 multiplied by t. 2 pi cancelled. T is coming. Shift. Take LCM. And your answer is coming T1, T2 upon, shift this over here. So this is coming T2 minus T1. So this is the time when both rods will be in same phase. For the given question, T1 is T, T2 is 4T divided by 4T minus T, or 4T divided by 3. So after 4T by 3 time, you will find that both rods, they are in same phase, or the particles which are executing simple harmonic motion, they are exactly in same phase. This is first method. It takes a lot of time to explain the first method, but you will see a shortcut which will make everything quite easy for you. But if you have understood this first method, if you have not, just don't worry. With the help of second one, things done in first one will also be clear. But I'm just asking you, if you have understood this first method, the value of time 4t by 3, this logic, these being equivalent, they are numerical values. So are you guys comfortable with this first approach, yes or no? Now let's understand this question with the help of circular motion, and in circular motion with the help of relative circular motion. What is relative circular motion? Look here. These are the two rods. This one is faster. This is rotating with 4 omega. This is rotating with omega. A1 and A2. And question is, at what time they both will occupy same position? If they both occupy same position, we'll say that they are in same phase. This is in ground frame. But now let's draw everything in the frame of A2. In the frame of A2, the slower rod. So when you say in the frame of A2, that means A2 becomes what? Observer. Observer, I hope you remember, is always at rest. So if observer is at rest, then it means, remember this is the answer which we got with the help of first method. So in the frame of A2, A2 is observer, observer is at rest. This is your A2. And this is A1. But this A1 is now rotating with what? For you, ground observer, it is rotating with 4 omega. For you, it is rotating with omega. But for omega, 4 omega is rotating with 3 omega. This is in the frame of A2. This is for ground observer. A2, remember, is at rest. And question is almost done. What is done? So you have two rods now. It doesn't matter what their lengths are. So you've got two rods. In the original setup, they both are rotating. One is slow and the other one is fast. But now you're saying that A2, it doesn't move. And the other one is rotating with 3 omega. Now the question is, after what time they both will occupy same position? After what time they both will occupy same position? To occupy same position, this A1 must rotate how much? By 2 pi. So if A1 rotates by 2 pi, if A1 rotates by 2 pi, it will align with A2. That means they both are in same phase. In what time an object covers 2 pi angle? If it starts with 3 omega. You need to find what? Time. The angle covered is what? 2 pi. What is time? Displacement upon velocity. What is angular displacement? 2 pi. What is angular velocity? 3 omega. So this A2 observer says that this A1 has to cover an angle of 2 pi with a speed of 3 omega, then it will align with A2. That means they both occupy same position. That means they both are in same phase. Done. 2 pi upon 3 omega. 3 omega. What is omega? Omega is 2 pi upon time period. What is the time period? 4t. We have taken omega 2 as omega. Omega is 2 pi upon time period, which is 4t. So if I put omega as 2 pi upon 4t, 2 pi cancel. It is coming 4t by 3. Same answer which you got from this. This was also giving us 4t divided by 3. This is your relative velocity approach. Are you comfortable with this second method, relative approach, yes or no? Good. And now for any competitive examination, just put the whole thing inside the boundary. It's a result for you. If they ask you a question like this, when two oscillators will be in same phase, what is the answer? T1 T2 upon T2 minus T1. It will just take 5 seconds from now on. If they repeat a question like this, there is no need for method 1, there is no need for method 2. Use the result directly. For the same question, answer the second part. Both rods start over here, and then you found that after 4t by 3, they are somewhere here. Before you answer the second part, tell me, we have taken the angle 120. Just for your understanding, I took the angle as what? 120. So the slower rod completed what angle? Can you tell me what this angle is basically? What is the angle which slower rod covers when the faster one is about to overtake it? Can you answer this? हमने 120 केवल न्यूमेरिकल वैल्यू अपने समझने के लिए लिया था, तो जब स्लो यहाँ पहुंची थी, फास्ट एक राउंड लगाकर वहां पहुंची हुई है. Can you tell me by looking at the result what this angle exactly is? Look, it's a very easy question I have given you. Forget about simple harmonic motion. I'm asking you that you have the speed, you have the time. Can you find displacement? That's what I'm asking you. So what I'm asking you is this. The slower rod, slower one, is moving with what? Omega. Slower rod is moving with omega. After this much time, after time t, what will be the angular displacement? But angular displacement is what? Angular velocity multiplied by time. So what is theta? Omega. What is omega? 2 pi upon omega 2 pi upon 4t. Multiplied by time. What is time? 4t by 3. 4t cancel. This is coming 2 pi by 3, which is nothing but 120 degrees. So I just took that value randomly, and you found that that is also the correct one also. So theta is coming what? 120. So the slower rod has only completed 120, whereas the faster one has completed 360 plus 120. If you remember questions which we did in kinematics, there is a car and a truck. So when truck is accelerated, truck is moving with some speed, and car starts with zero initial speed, but it has some acceleration. The questions were like this, if you remember, and if you don't remember, you can even feel this thing. So if I say that the black one initially has some speed and the blue one starts, so after some time it is going to overtake. So you can find time with the help of relative motion. But if I ask you what is the distance covered by these things, what is distance? Distance is what? Speed into time. So right here we are interested in angular distance or angular displacement, which is angular velocity multiplied by time. Now you'll also feel this 120 after some time, but let's try to answer the second part of the question. Write down the second part. After what time both oscillators, that means both rods, after what time both oscillators will be at initial position. After what time both oscillators will occupy same initial position. So again they are in same phase. Technically they are in what? Same phase. But this time they have to meet at the starting point itself. In the previous question you found that something like this happens. It overtakes and then meets over here when angle is 120. Now the question is that if this thing continues, then after what time they both will be in same phase, but that same phase is now what? They both meet at the initial position itself. So try to answer this. Look, ये पिछले वाले से भी ज्यादा इजी है. कैसे इजी है देखना. Let's draw these two rods separately. This is the initial moment, T0. I'm just writing 0. Remember, this is the time, T0. What happens after time T? After time capital T, what happens? What is capital T? Time period of the first one. Time period of the first one, that means after time capital T, this rod will complete one rotation. After capital T, first rod completes one oscillation, that means one complete circle. What about this? Its time period is what? 4t. That means in time t, it will only cover 1/4. So when time is t, the second rod is over here. Its time period is 4t. It can only cover what? 1/4 oscillation. Again, what about another time t? After another time t, this rod again completes one rotation. 2t. They all are the same position. I am drawing separately. First round, second round. So after 2t time, this will be found here. After third round, this will be found here. After fourth round, this will be found here. 40, 40. They both are pointing in the same direction and are at their respective mean positions. Something like this happened. After time t, what happened? After time t, this covers 1/4, one complete round. Another t, complete round. Another t, complete round. Another t, complete round. They both are pointing in the same direction. So the question is, after what time they are in the same phase and are at the initial position? Answer is 4t. 4t. Which you can also see in this. कैसे? ये कौन सा टाइम था? When they are in same phase, but they don't have to be at the starting point. What is this? The faster one, forget about the color and all, the faster one overshoots, the faster one overshoots and then catches up with the slower one again. This 4t by 3. So after 4t by 3, they are in the same phase. And angle covered is what? 120. I told you that will feel 120. So this angle is what? 120. What is time? 4t by 3. What is this? Both rods initially 0, time 0. 4t by 3, the faster one over here. Now, जैसा ये था, अब एक तरह से वैसा ही ये है. तो अगर यहां से शुरुआत करोगे तो कुछ देर बाद ये यहां मिलेगा. 120 के बाद जहां भी होते हैं उसके 120 के बाद दोनों का अलाइनमेंट होता है. यहां से 120 के बाद, दैट मीन्स स्टार्टिंग से कितना टाइम हो गया? 4t by 3 प्लस 4t by 3. यहां से 120 के बाद दोनों रॉड यहां होगी. जब यहां होगी टाइम क्या होगा? 4t by 3 plus 4t by 3 plus another 4t by 3, which is 4t. क्या बोला मैंने? यहां से चले थे, एक स्लो एक फास्ट, फिर यहां से चले एक स्लो एक फास्ट, फिर यहां से चले एक स्लो और दूसरा कंप्लीट राउंड फास्ट, and it aligns. That means starting from this, after what time? 4t by 3 plus 4t by 3 plus 4t by 3, which is 4 capital T. Or 120 plus 120 plus 120 is what? 360. Do you understand this part? 40, 40. Are you comfortable with this? Let's see how much you have understood this profile. Let's say there are two oscillators with these time periods 3t and 4t. There are two oscillators with time periods 3t and 4t. Answer both parts. The first part is when they are in same phase, and the second part is when they meet at the starting point. In the first part, they can meet anywhere. The only requirement is that they must subtend same angle with the initial. In the second part, they must meet at the mean position itself. So it's like two oscillators. Look, there are two oscillators. So if one is fast, then they will lose the synchronization. So what you found that in the previous question, after a time of 4t by 3, you found that they are somewhere here. In the second part, after a time of 4t, you found that after a time of 4t, they both are at the mean position and going this way, and going this way. So the question is that if time periods are 3t and 4t, then answer both parts. Let's see how fast you are. Well, at least you can answer the first part. The first part I have given you what? Result. So this first part is something everybody can answer in just 5 seconds. 4 into 3, 12 t. 4 3 minus 3t. So answer for the first part is simply what? 12t. Now try to answer the second part. Answer for the first part is 12t. So look at the second. Second thing says that this is your first T1, this is second T2. Two rods, they start with this mean position, initial position, and they are rotating this way. The second part means दोनों ने जब भी मिलना है, question says when for the very first time they both are at their respective mean positions. So there are two oscillators, they start from same mean position, they start oscillating, one is slow, the other one is fast, but the question is after what time you will find that they both arrive at their mean positions. They both simultaneously arrive at their mean positions. So how do you answer something like this? If I say that T1 arrives at this position, I have no idea how many oscillations or how many rounds it has completed. In the previous example, you saw that one oscillator completed one oscillation and the other one completed 4 oscillations. In this question, I have no idea. So what I say, This T1, let's say, completes N1 oscillations. When it is back at this position, it has completed 3, 4, 5, 6, I have no idea, N1 oscillations. This one has completed N2 oscillations. They both started at this time 0. At this time 0. These are the time periods. So they both start when time is 0. T is 0. T is 0. And after time T, they are back at that same position. Question is almost done. One oscillation requires what time? T1. How many oscillations? N1. So what is the time taken? N1 into T1. Time T for the second one is N2 T2. N1 oscillations complete करने में इस फर्स्ट वाले को कितना टाइम लगेगा? One oscillation T1, two oscillations 2T1, three complete oscillations 3T1 complete because हमें कहाँ मिलना है? स्टार्टिंग पॉइंट पर. तो अपने को पता नहीं कितने oscillations हुए, हमने बोला N1 है. After N1 oscillations कहाँ मिलेगा? टाइम क्या हो रहा होगा? N1 T1. But exactly at the same time, the second one has completed N2 oscillations. N1 upon N2 is coming T2 upon T1. What is T2? 4T. What is T1? 3T. What is this? 4 by 3. What does it tell you? It tells you that N1 is 4 and N2 is 3. N1 and N2, they are integers. So they are integers, then N1 is coming what? 4 and N2 is coming what? 3. Which means what? जितनी देर में पहले वाले ने 4 oscillations complete किए हैं, उतनी ही देर में दूसरे वाले ने कितने oscillations complete किए हैं? 3. पूछा गया था टाइम. What is time? कोई सी भी एक वैल्यू चूज कर लो, this or this. If I use this, what is N1? 4 multiplied by T1, 3D. अब इसे यूज कर लो. What is N2? 3. What is T2? 4D. So after what time they meet at the starting point? 12T. Same as this. Same as this. This time you will never find something like this. You will never find something like this. If they align themselves, then it will always take place exactly over here at the respective mean positions. 12T. Are you comfortable with this? Yes or no? Let's see how active you are. We've got a result for first profile. If they ask us when they are in same phase, wherever that position be, the answer is T1 T2 upon T2 minus T1. For the second type, where question says they must meet at the starting position itself. For that, in the previous question, values were t and 4t. And answer was 4t. This time values are 3t, 4t, and answer is 12t. What is 4t of these two? What is 12t of 3t and 4t? And you got your result. What is 4t of t and 4t? And what is 12t of 3t and 4t? Write down in the comment box. Taking too long. What about LCM? What is LCM of 3 and 4? 12. What is LCM of t and 4? 4. So if they ask you the second profile, now the result is what? LCM of T1 and T2. So the second type. And this is nothing but process of finding LCM. This you see is nothing but process of finding LCM. For the second part, you have the result. So the entire lecture was devoted for two profiles, two results. Solving it takes a lot of time, but now if these things are asked in any competitive examinations, just remember what? For the first type, they can meet anywhere. Second type, they must meet exactly at the same position. Try to answer this. T1 is 6 seconds. T2 is 9 seconds. Answer both parts, first and second. T1 is 6 seconds and T2 is 9 seconds when they will be in same phase for the first time, first part. When they will meet for the first time at the starting mean position, at the second part. I don't know why it should take this much time. For the first part, answer is 9 into 6 upon 9 minus 6, which is 18. For the second part, LCM of 9 and 6, which is also 18 seconds. Why 18 seconds? This is 6, this is 9. So one is 6 and the other one is 9. जिसका टाइम पीरियड 6 है वो आफ्टर 3 rounds 3 rounds means 6 6 6 18 seconds same position पर आ गया. The other one which is moving with 9, which has the time period of 9, one time period, one round 9, another round 18. And since both are same, before 18 seconds, it never happens that they are like this. They are in same phase once they are back at the रेस्पेक्टिव मीन पोजीशंस। तो अब इस तरह के क्वेश्चंस को करने में इट शुड नॉट टेक मोर देन 5-10 seconds. I hope today's lecture was you could understand everything, not a difficult part. It's about taking LCM, it's about relative motion and all. And even if you're a bit confused, watch the recording again. And even if you don't watch the recording, remember these two results. Note down everything and then you can leave. Thank you very much.